All right, guys. So as I was saying, before we were interrupted by the Zoom, based on the first situation that we'll have. All right, so let's just rewrite it. So we have, so I'm going to put 1, 2 in it. And then now I'm going to use 3, 1, 3, 5. All right, so 3, 5. And then we have 1, 6. All right, and then now we were asking Ms. Cabrera how many rows and how many columns for the second one, and she said we have 1 row by 2 columns, right? And then now for the second matrix, you were saying now, Ms. Cabrera, we have how many rows, how many columns?
2 rows.
2 rows. So that would be a 2 by 2 order, right? Now, the next question I want to find out now, can these 2 matrices be multiplied? And that's your question, Ms. Cabrera. Ms. Cabrera.
Repeat.
Can we multiply these 2 matrices together?
No.
Now, when you look at the rows for the, how many rows you have for the, sorry, not rows. When you look for the columns of this first matrix, how many columns you have in the first matrix? 2, right? How many rows you have in the second matrix?
2.
All right. Are these 2 numbers the same? I didn't hear that, Ms. Cabrera. Go again.
Yes, sir.
Was that a yes?
I mean, the 2
This number and this number, are they? Right. So it means that these 2 numbers are equal. Right? Now, this is the condition that tells you that you can multiply. Once these 2 numbers are the same, it means that you can multiply them. Now, in the other one, we had 1 equal to 2. So it means the number of columns in the first matrix was 1. The number of rows in the second matrix was 2. Are these 2 numbers the same? Ms. Cabrera?
No.
No. So they are not equal. And once these 2 numbers are not equal, it means that you cannot multiply the 2 matrices. You following what I'm saying?
Yes.
Right. So that in order for you to multiply 2 matrices, you have to check the column and the row, check the column in the first matrix and check the row in the second matrix and ensure that the 2 numbers are the same. And if the 2 numbers are the same, it means that you can multiply the 2 matrices. So that's what I'm saying to you. So do you understand that now?
Yeah.
Right. So that's it. That's this. This is what I'm referring to as a condition that you must have before you can multiply. So if this is not satisfied, if the columns in the first don't equal to the rows in the second, it cannot be multiplied. The 2 matrices cannot be multiplied. All right, guys. So that's something that you have to bear in mind when you're carrying out multiplication of 2 matrices. All right, so I'm going to clear this and move on. So here now, the question now, can we multiply the matrix R with the matrix S?
Yes.
Right, because when we do that check, we know that this is a 2 by 2. This is also a 2 by 2. And it means that this column and this row have the same numbers, so we know we can multiply. All right, so when we are multiplying now, what is the rule that we follow when we multiply? So let me clear what we have here, because I don't want you to confuse these. So now we know that it can be multiplied. How do we multiply? What is the rule for multiplication of two matrices? How do we multiply matrices?
So you multiply the first number in the first row and column with this first number in the second row and column.
All right. So in other words, we multiply rows by columns by multiplying their corresponding elements together, and then add the two of them. So in terms of the first row, so we use the row in the first matrix times the column in the second matrix. That's for multiplication. So when we are multiplying now, we take the first element in the row of the first matrix times the first element in the column of the second matrix. So we multiply 1 times 3. So we put down 1 times 3. And then now we do the second element, 2, second element in the row with the second element in the column, and we multiply 2 times 5. But what we're going to do now, we're going to add the products. So 1 times 3 plus 2 times 5. Right? And then this one would give you the top element on the left-hand side in the result. So it means that we have to now use the same row with the second column to get the top element over here. So can you walk me through the process of what would we get over here? So I'm going to ask each person to help me to calculate each of these. So starting with Miss Waysome, for these top elements over here, we are multiplying this row, the top row, with the second column. So tell me what I should write down here, Miss Waysome.
So sorry, it should be 1 times 1.
So 1 times 1. So we should have 1 times 1 here. Continue.
Plus 2 times 6.
Plus 2 times 6. All right, so we are saying 1, taking back the same one, using the first element in this row, the first element in the column, multiply them together 1 times 1. Then we now use the second element in the row, 2 times the second element in the column. So that would be 2 times 6. And so we'll get that. Now, after we are through with this first row, now we have to move on to the second row and go back with the 2 columns under in the second matrix again. So let me erase these. And now we're going to use the second row with the same 2 columns to get the 2 bottom elements down here. So I'm going to ask Ms. Cabrera now to give me the calculation for the second row in the first matrix with the first column. So tell me what I should write down here, Ms. Cabrera.
3 times 3 plus
3 times 3
plus 4 times 5.
plus 4 times 5. Correct. All right. Good. Now, Miss Dorothy, can you tell me now can the second row with the second column of this second matrix? What do we have here now?
So with 2 times 1.
Remember now, Miss Dorothy, we're using the second row,
Oh,
second column.
Three times 1, sir.
So we have 3 times 1.
Plus 5 times 2.
Let's start. Go back again. The first one is a 3
Times 1.
times 1. Remember, is the second column. Then we're going to have what now? Remember, we are using the numbers in the row now. So we use it here already. Which other number we're going to use? Look at the numbers in this in the second row here, Mr. What are the numbers in the second row?
3 and 4.
Right. So if we use the 3, which other one we're going to use?
The 4.
The
Times
4. So we're going 4. What we're going to multiply with the 4?
4 times 6.
4 times 6. Correct. So we would have 3 times 1 and 4 times 6. All right. So now, Miss Green, what would be the sum of the products of the first number here?
13, sir.
All right, so we have 13. Miss Dorothy, what is the sum of the product of the top number on this side?
13.
All right, so we'd have 13 here. Miss Cavera, this one is how much we have here, sir?
20.
I only hear the 20, but I'm not getting the last one.
29, sir.
All right, 29. All right. And Miss Waysam, give us the last one.
19, sir.
Say that again.
19.
Okay, 19. Good. Right, and that's how we get our product of multiplying the matrix R times the matrix S. All right, so that is just a recap for you guys in how to multiply two matrices. Now, yes, Miss Green, go ahead.
I don't think the answer for the last one is 19.
Oh, well, let us check it again. So we have so let us check it quickly, just to be sure. So all right, so let us run through. So we're going to use the first row with first column. So it would be 1 times 3, 3 plus 2 times 5, 10. 10 plus 3 give you 13 for that one, right? Now, first row again with second column. 1 times 1, 6, 2 times 6, 12. 12 plus 1, 13 again for that one. All right, so we have second row, first column now. 3 times 3, 9. 4 times 5, 20. So 29 for that one. All right. So now let us check this last one now. So we say that we're using the second row now with the last column or the second column. So 3 times 1, 3, and 4 6s, 24. All right, so there was an error there in that calculation. So 3 1s 3, 4 6 is 24. That would give you 27. So we should have 27 here. All right. Now the error is not so much a calculation. I guess it was just how the numbers were written.
Yes, sir, because I thought it was 4 times 4. So I was
Yeah,
like 4, 4, 16, and then,
It was just how the numbers were written, and because it is not properly, it's
Yeah.
not very clearly written. So I figured that was the problem. All right, so that would be the answer to that solution, to this product. All right, so everybody get the general idea. So now here, this is what we're supposed to have when we find our products for this one. Now, your task now is to carry out this multiplication and produce an answer for us. All right, so you're going to tell me what the answer should be for the result. So I'm giving you 3 minutes to do that. When you're finished, raise your hand so that we can work through the solution together. All right, guys, go ahead now and do your calculation. Okay, Ms. Cabrera, you have an answer?
Yeah.
All right, let us write down what you have as your answer down here. What is your answer?
-4.
-4 right there.
Yeah.
And then going across or going down?
Going down, you have -5.
-5. All right.
Then you have -2.
At the top.
Yeah.
Mhm.
And then
And then
1.
1. Okay. All right. So that's Ms. Cabrera's answer. Anybody else finish and want to share the answer? All right, go ahead, Miss Green. Give me your answer. Let me write it down.
Sir, I got -4,
-4.
-2,
Going down or across?
going down,
-2.
-2 again.
At the top.
Yes, sir.
-2 at the top.
Negative.
How much? -1?
Yes, sir.
Okay. All right, good. Anybody else with answer? Want to share? Ms. Dorothy, do you have an answer to share with us?
I'm almost finished, sir.
Okay. Ms. Waysome, how about you?
Sir, I'm on the road. I'm not home as yet to attempt the question.
Oh, so you didn't get a chance to attempt the question then. All right, so all right, let us just see what the result should be. How far are you? Something, Miss Waysome? Someone was saying something just now. Who was that? I'm not sure. Was that you, Miss Waysome?
Yes, sir. I was saying I'm not hearing you.
Oh, so I was just asking Miss Dorothy how far she is now, if she's finished with her answer, so that we can compare them, because I'm going to just give the solution. So Miss Dorothy, are you finished with your solution?
Yes, sir.
All
Sorry,
right,
I have
what you have?
-4,
-4.
-2,
Down or across?
across, sir.
Yes, go ahead.
Then I have -5.
Down from -4.
Yes, sir. Then +1 below number 2.
+1. All right. Okay. This is Miss Green, right? Miss Green here. Is that yours, Miss Green? Second one? Miss Green,
Yes, sir. The last one is mine.
that is yours. And this one is Miss Cabrera.
Yes, sir.
And this is Miss Dorothy. All right, so let us see if anybody have the same answer. All right, so Miss Dorothy and Miss Cabrera seem to have the same answer. And Miss Green is a little different. All right, let me reveal the answer.
-2 times 2, -4 plus 0 times 3 as 0.
All right.
-4 times -2
All right, so let us check.
plus 0 times 3.
So we're doing Q first. So we're doing P and Q first. So when we multiply P times Q, we get this. So now after we get this, we're going to use this now to multiply R. So we would get that. And so the correct answer here would be Miss Green. All right, so let us see what Miss Dorothy and Miss Cabrera would have missed out on. Are you able to spot your error, Miss Dorothy or Miss Cabrera?
I'm rechecking it, sir.
Miss Cabrera, are you able to spot your error? Because it seems that it is just a sign. No, it wouldn't be the sign, because you would have off by this number. And this, so these numbers are off. All right, so you need to check these numbers. How you get that. All right, so let me walk you through the process. Right, so did everyone get this when did you do PQ first and get this? Raise your hand. Anybody? All right. You got PQ to be that to Miss Dorothy. Did you do PQ first? Because remember, now you're multiplying 2 at a time. So you multiply these 2, you get one product. Then you take that product and multiply by R. All right, so let me work out this one to verify this. So we have 2 times -1, 2 times -1, 0 times 0. When we add -2 plus 0, we get -2. So this one is correct. All right, for this one over here now, we have 2 times 0 give us 0, 0 times 1 give us 0. So this is correct. Now we have 1 times -1 give a -1, 0 times 1 give us 0. So this one give you -1 when you add them. All right. So now for this one, 1 times 0 give you 0 plus 0 times 0 give you 0. So this is correct. So you should get this when you do PQ. All right, so after PQ now, we write the PQ first, which is this, and then we write the R after, which is this. So this is the PQ part, and this is the R matrix. So this is the PQ product matrix, and this is the R matrix. So we're going to multiply these 2 together. So -2 times 2 will give you -4. So -2 times 2 will give you -4, and we're going to add that to 0 times 3. 0 times 3 gives us 0. So -4 plus 0 will give you -4. All right, so that's correct so far. All right, so now for this one, over here, for the second column, we're going to take the same first row. So -2 times 1 will give you -2, and 0 times 0 will give you 0. So we add -2 plus 0, we get -2 here. So that's, everybody seemed to have that in their solution. So nobody had a problem with that first row in terms of the solution. So apparently now the problem for those who didn't get it correctly would be in the second row. So let us look at the second row now. All right, so we're using the second row, and then we're going to use it by the first row. So we have -1 times 2 give you what? -2. And then we're going to add 0 times 3 will give us 0. So -2 plus 0 will give you -2. All right. So So this -5 here would not be correct. So that means there's an error in your calculation there. Now, to do this one, we're using the same second row with the second column. So we say -1 times 1, -1, and 0 times 0. So we have -1 plus 0, we get -1. Now, guys, were you able to see where you went wrong? For those who did not get it correct?
Yes, sir.
Okay, all right, good. Sorry, we can move on then. All right, so moving on. Some matrices matrix notation. So when we talk about notation, you should know by now that the word notation is a big word for symbol. So if you read it, matrix symbol, matrices are usually denoted by capital letter. So we use a capital letter to denote the matrix, or in other words, to label or to name the matrix. So A equal to the matrix 3174. So A, when we refer to A, we know we're talking about this matrix. Now B refer to 2 and 3, it's a column matrix. So whenever we see B, we know which matrix we are referring to. All right, so that's the matrix, the matrices are labeled with capital letters, or we name them with capital letters, or we denote them with capital letters, all right? Now, there are some things to note about matrices, all right? Now, oftentimes, so we have 4 things here. I'm going to go through them one at a time for you to get clarification. All right, now, if we multiply two matrices, and we have A times B, and then we flip the 2 matrices around, and then we multiply B times A, we don't get them to have the same answer. Now, remember that when we were looking at addition and multiplication of numbers, we could usually switch, say 3 times 2. And if we switch it around and say 2 times 3, we will get the same answer to be 6. Sorry, all right, 6 instead of 3. So 2 times 3, and when we multiply them out, we get the same answer. So because this side, when you flip it around, produces the same answer, we say that multiplying numbers are commutative, right? And in some cases, some people pronounce it as commutative, all right? Now, what you can say about the commutative properties of matrices, you will notice that matrices are not commutative, meaning that when you start off with the matrix A times the matrix B, you don't get the same result as when you start off with the matrix B and times the matrix A. So that's something to bear in mind. So the order that you use to multiply the matrices will determine what the result will be. So if you start with matrix A and times it by B, it won't be the same result if you start with matrix B and multiply it by A. Is that clear, guys? Raise your hand if that first note is clear. All right. Now, when we talk about A squared for a matrix, so let's say that the matrix A is equal to oops, sorry. This thing is having its own way with me today. So let's say 1, 2, 3, 4. Can somebody tell me if we find if A is equal to that matrix? Can somebody tell me what the answer of A square, what the answer of A square will be? What will A square give you in terms of the answer? Can anybody tell me?
Or, A times A.
What's the answer? What's the answer you're going to get?
Oh, for the, so you have 1 times 3 and 2 times 4.
No,
Sir, Sir, would it be?
Yeah, go ahead.
Sir, would it be 1, 4, 6,